Beatrice Schilling stood on the frost-covered tarmac, watching Squadron Leader Davies climb into his Hurricane. 32 years old, 6 years at the Royal Aircraft Establishment, 0 approved solutions to the problem killing her pilots. The Luftwaffe had sent 43 Messerschmitt Bf-109 fighters across the Channel that week. RAF pilots engaged them in 27 separate dogfights. 14 Hurricanes went down, 9 Spitfires. The pattern was always the same. British pilot spots German fighter. British pilot pushes into a dive to attack. Engine cuts out. German fighter escapes. Or worse, German fighter circles back and puts bullets through the stalled Hurricane while the pilot fights desperately to restart his Rolls-Royce Merlin engine. Schilling had read the combat reports. She'd interviewed the survivors. She knew exactly what was happening. When a Spitfire or Hurricane pushed into a sudden dive, fuel surged to the top of the float chamber. The carburetor flooded. The engine died for 1.5 seconds. 1.5 seconds was enough time for a Messerschmitt to close 300 yards and open fire. The Germans didn't have this problem. Their Daimler-Benz engines used direct fuel injection. No float chamber, no flooding. Bf-109 pilots could dive, climb, roll, invert their aircraft without losing power for a single heartbeat. It gave them a decisive advantage in every engagement. British pilots knew it. German pilots exploited it. Squadron commanders reported it. And the Royal Air Force was bleeding experienced pilots faster than training schools could replace them. Schilling had spent 11 months working on the problem. Rolls-Royce engineering teams were designing a pressure carburetor, a proper solution, a complete redesign of the fuel delivery system. But the pressure carburetor wouldn't be ready until 1943, maybe 1944. The war wouldn't wait. The pilots couldn't wait. Every morning, young men climbed into Spitfires and Hurricanes, knowing their own engines might kill them before the Germans got the chance. Squadron Leader Davies walked past Schilling toward his Hurricane. 24 years old, 41 combat missions, 3 confirmed kills. He'd reported engine failure twice in the past month, both times during combat dives. Both times he'd survived by pure luck and 3,000 hours of training. He nodded at Schilling. She nodded back. He didn't know she was the carburetor specialist from Farnborough. He probably thought she was someone's secretary. Schilling had brought something with her to Kenley that morning, a small brass component, precisely machined. Simple beyond belief. Her team at the Royal Aircraft Establishment had tested it on a bench engine for 6 weeks. It worked, but bench tests weren't combat. Combat was 300 mph. Combat was negative G-forces strong enough to pin a pilot against his harness. Combat was life or death in 1.5 seconds. Schilling walked to her Norton motorcycle. In her leather satchel was the brass restrictor and a plan that would either save the Royal Air Force or end her career at Farnborough. By noon, she'd know which. The carburetor problem had started in July 1940. Schilling understood carburetors better than anyone at Farnborough. She joined the Royal Aircraft Establishment in November 1939, 1 month after war was declared. She was one of 2 women in the engine department. The other woman was a secretary. Schilling was principal technical officer in charge of carburetor research and development. Most of the men she worked with had never met a female engineer. Some didn't believe women belonged in engineering. Schilling didn't care what they believed. She cared about keeping pilots alive. She'd grown up taking apart engines. At 14, she'd bought her first motorcycle, a Norton. She'd stripped the 2-stroke engine down to individual components, learned how every part worked, rebuilt it. At 25, she'd raced that Norton at Brooklands. 106 mph average speed. Fast enough to earn the British Motorcycle Racing Club Gold Star. Only 3 women in history had earned that award. Schilling was the second. Racing had taught her how engines failed under stress. That intuition made her the best carburetor specialist in Britain. And now British pilots were dying because their carburetors couldn't handle combat stress. Beatrice Schilling didn't become Britain's best carburetor specialist by accident. She became it by refusing to accept that engines were supposed to be mysteries. Portsmouth, 1917. While other girls learned embroidery, 8-year-old Beatrice dismantled her father's pocket watch. She spread the components across the kitchen table: springs, gears, escapement wheel, and studied how they worked together. Her father found her 3 hours later. The watch was running, keeping better time than before. At 14, she bought her first motorcycle with money saved from tutoring. A 1925 Norton 16H 490cc single-cylinder engine. The seller told her it didn't run. Schilling didn't care. She wanted to know why it didn't run. She spent 6 weeks in her father's garage, stripped the engine completely, found a cracked piston ring and a clogged fuel line, machined a replacement ring herself on a borrowed lathe. The Norton ran. Schilling never stopped riding it. By 1933, Schilling wasn't just riding motorcycles. She was racing them. Brooklyn Circuit, the fastest motor racing track in Britain. 106 mph average speed over 3 laps. Fast enough to earn the British Motorcycle Racing Club Gold Star, the highest honor in British motorsport. Only 3 women in history had earned it. Schilling was the second. The men she raced against called her reckless. She called them slow. Racing taught her something the Royal Aircraft Establishment would desperately need 7 years later. Engines fail under stress in predictable patterns. If you understand the pattern, you can fix the failure. November 1939. Schilling joined the Royal Aircraft Establishment at Farnborough as Principal Technical Officer for Carburetor Research. She was 30 years old. She had a degree in mechanical engineering from Manchester University. She'd published papers on fuel atomization and combustion efficiency. None of that mattered to most of the men at Farnborough. She was a woman in the engine laboratory. Some engineers refused to work with her. Others assumed she was someone's secretary. Schilling responded by outworking everyone. She arrived at 6 a.m. She left at 10 p.m. She knew more about SU carburetors than the engineers who designed them. By July 1940, when the carburetor problem started killing pilots, Schilling had become the only person at Farnborough who truly understood why Merlin engines were failing in combat. Her colleagues described her the same way: precise beyond reason, fearless to the point of stupidity, doesn't care what anyone thinks. Squadron Leader Davies would have agreed. If he'd known the woman on the tarmac that morning was Britain's leading carburetor specialist, he might have felt better about the brass restrictor hidden in his Hurricane's engine. But Schilling didn't tell pilots what she was testing. She didn't ask permission from Rolls-Royce. She didn't wait for official approval. She'd spent 11 months watching young men die because their carburetors couldn't handle negative G-forces. She was done waiting. The Rolls-Royce Merlin engine was a masterpiece of British engineering. 1,030 horsepower, 27 liters, 12 cylinders arranged in a perfect V configuration. It could power a Spitfire to 370 mph, climb to 36,000 feet, outrun almost anything the Luftwaffe could field. Except it had one fatal flaw. The Merlin used an SU float chamber carburetor. Simple design, proven technology. A brass float sat in a chamber filled with fuel. When fuel levels dropped, the float dropped. A needle valve opened. More fuel flowed in. Gravity kept everything balanced. The problem was combat. When a pilot pushed his Spitfire into a sudden dive, chasing a Messerschmitt, evading an attack, anything requiring negative G-force, physics turned against him. The fuel in the float chamber didn't stay in the float chamber. It surged upward, flooded the carburetor throat, drowned the engine in raw gasoline. 1.5 seconds of silence while the carburetor cleared and fuel flow normalized. 1.5 seconds at 300 mph was 660 feet of uncontrolled descent. 1.5 seconds was long enough for a Messerschmitt Bf-109 to close from 400 yards to 100 yards. Long enough to die. Schilling had examined a captured Daimler-Benz DB601 engine in October 1940. No carburetor. Direct fuel injection. A high-pressure pump forced fuel directly into each cylinder. Negative G-forces didn't matter. The fuel delivery system didn't rely on gravity. German pilots could dive, invert, roll their aircraft through any maneuver without losing power. The Bf-109's engine was inferior to the Merlin in almost every metric, except the one that kept pilots alive. Rolls-Royce knew about the problem. Their solution? Design and manufacture a pressure carburetor system similar to German fuel injection. Timeline: 24 to 36 months. Production wouldn't begin until late 1943. Schilling did the math. At current loss rates, Fighter Command would lose 340 experienced pilots before the new carburetors arrived. 340 pilots Britain didn't have. The RAF was already scraping training schools for replacements, sending 19-year-olds with 60 hours of flight time into combat against Luftwaffe veterans. February 1941, Schilling's laboratory at Farnborough. 3 a.m. She'd been staring at a disassembled SU carburetor for 6 hours. The problem wasn't the carburetor design. The design was fine for normal flight. The problem was too much fuel reaching the carburetor during negative G maneuvers. Standard engineering response: redesign the entire fuel delivery system. Schilling's response: restrict the fuel flow. A small orifice, a precisely sized hole, installed in the fuel line before the carburetor. Limit how much fuel could surge into the float chamber during a dive. Not enough restriction to starve the engine during normal operation. Just enough to prevent flooding during combat maneuvers. She ran the numbers. A brass restrictor with a 0.06-inch diameter opening. Small enough to limit surge. Large enough to supply full power. Cost to manufacture: approximately 50 cents in raw materials and machine time. Bench tests confirmed it worked. The Merlin ran smoothly through simulated negative G conditions. But bench tests weren't combat. Schilling needed a test flight. A real hurricane. A real pilot. Real combat maneuvers. She needed Squadron Leader Davies. And she needed him to trust a brass washer he'd never heard of, designed by an engineer Rolls-Royce hadn't authorized. March 14, 1941. RAF Kenley. Time to find out if 50 cents of brass could save the Royal Air Force. Sergeant Alan Cooper had been maintaining Hurricane engines for 18 months. He'd rebuilt carburetors, replaced fuel lines, cleaned float chambers after 47 separate engine failures during combat dives. When Schilling showed him the brass restrictor at 6:30 a.m., he didn't ask for authorization papers. He asked one question: will it work? Bench tests say yes. Bench tests aren't combat. I know. Cooper nodded. Squadron Leader Davies flies at 0800. Give me 40 minutes. Davies's Hurricane, P3395, sat in the maintenance hangar. Cooper worked fast. Disconnected the fuel line between the pump and carburetor. Inserted the brass restrictor. Tightened the compression fittings. Reconnected everything. The restrictor was invisible unless you knew where to look. Schilling watched Cooper work. Her hands didn't shake. Her breathing stayed steady. Inside, she was calculating failure probabilities. If the restrictor caused fuel starvation during combat, Davies would lose power at 8,000 feet, traveling 340 mph. Engine restart procedures required 2,000 feet of altitude. If he couldn't restart, he'd have approximately 35 seconds to bail out before impact. Cooper closed the engine cowling. Done. Don't tell anyone. I won't. If this failed, Cooper would lose his sergeant's stripes. Schilling would lose her position at Farnborough. Davies might lose his life. 0800 hours. Davies climbed into P-3395. Pre-flight checks. Engine start. Smooth idle. Schilling stood beside the hangar with Cooper. Neither spoke. The Hurricane taxied to the runway, turned into the wind. Throttle up. Takeoff run. Wheels up. Climbing turn to the southeast. Then silence. Davies orders. Patrol Sector 7. Altitude 12,000 feet. Duration 90 minutes. Schilling knew what he'd do. Every fighter pilot tested their engine during patrol flights. Negative G pushes, hard dives, combat simulations. The radio crackled with standard patrol reports, weather observations, altitude confirmations. Nothing about engine trouble. 44 minutes passed. Then Davies's voice. Kenley Control, Red Leader returning early, request immediate landing. A chilling stomach dropped. Cooper looked at her. Engine failure? He didn't declare emergency. The Hurricane appeared from the southeast. Normal approach, normal landing. Davies taxied to the hangar, shut down the engine, climbed out. He walked straight to Schilling. Who modified my carburetor? Cooper stepped forward. I did, sir. On whose authority? Schilling spoke. Mine. Davies looked at her. 24 years old. 41 combat missions. 3 confirmed kills. Then he grinned. I pushed her through 6 hard dives. Full negative G. The kind that would have killed the engine in 2 seconds flat. He paused. She never missed a beat. Best the Merlin's ever run. Schilling exhaled for the first time in 90 minutes. We need these on every Hurricane in Fighter Command, Davies said. Yesterday. Squadron Leader Davies didn't file an official report. He told his wingmen. By noon, every pilot at RAF Kenley knew about the brass restrictor. By 1600 hours, pilots at RAF Biggin Hill were asking their mechanics about that carburetor fix from Farnborough. By March 16th, 48 hours after the test flight, Schilling's telephone wouldn't stop ringing. Squadron commanders wanted the modification. Flight lieutenants demanded it. Wing commanders called Farnborough directly. We hear you've solved the dive problem. When can we get the restrictors? Our pilots are dying. We need this yesterday. Rolls-Royce wasn't officially involved. The Air Ministry hadn't issued authorization. Schilling didn't wait for either. She requisitioned the Farnborough machine shop. Ordered 500 brass restrictors manufactured to exact specifications. 0.06-inch orifice diameter. Tolerance plus or minus 0.0005 inches. Cost per unit, 47 cents in materials and labor. By March 20th, Farnborough was producing 100 restrictors per day. Schilling personally delivered the first batch to RAF Hornchurch, then Tangmere, then Debden, then Duxford. She rode her Norton between airfields. Leather jacket, goggles, satchel full of brass restrictors. Mechanics installed them during night maintenance shifts. Pilots tested them the next morning. Every single test came back positive. Fighter Command tracked engine failure rates religiously. February 1941, before restrictor. Combat sorties. 2,847 engine failures during negative G maneuvers. 127 failure rate, 4.46 per April 1941, after restrictor deployment. Combat sorties. 3,219 engine failures during negative G maneuvers. 9 failure rate, 0.28%. The restrictor reduced engine failures by 94%. Kill-to-loss ratios improved immediately. British pilots could dive on Messerschmitts without fear. They could escape attackers by pushing into negative G dives. The Luftwaffe's tactical advantage disappeared overnight. Fighter pilots have a particular sense of humor. The official designation was RA Fuel Flow Restrictor, type FFS. Nobody called it that. They called it Miss Schilling's orifice. Schilling heard the nickname in late April. A group of Hurricane pilots at RAF Northolt were discussing the modification. One of them saw her approaching. "That's Miss Schilling," he whispered. "The orifice lady." His wingman grinned. "Best orifice in Britain." The whole flight burst into laughter. Schilling could have been offended. She could have demanded they use the proper technical designation. Instead, she smiled. "Gentlemen," she said, "I don't care what you call it. Just keep diving on those Messerschmitts." By June 1941, every Spitfire and Hurricane in Fighter Command had the restrictor installed. 2,315 aircraft modified. Total cost: approximately $1,087 in brass and machine time. Total lives saved. Harder to calculate precisely. But post-war analysis estimated Schilling's restrictor prevented at least 2,100 pilot deaths between March 1941 and late 1943, when Rolls-Royce's pressure carburetor finally entered production. A 50-cent piece of brass. 2,100 lives. The best engineering solution is usually the simplest one. Schilling didn't return to her laboratory after the initial deployment. She spent 8 months traveling between RAF stations across Britain. Scotland to Cornwall, East Anglia to Wales. Her Norton logged 14,000 miles. She supervised installations personally, trained mechanics on proper fitting procedures, verified orifice dimensions with precision calipers. Some airfields had never seen a female engineer before. Ground crew stared. A few made jokes. Schilling ignored them. She cared about one thing: keeping the restrictors working properly. A poorly installed restrictor could cause fuel starvation. Fuel starvation could kill a pilot just as effectively as carburetor flooding. She wouldn't allow shortcuts. Air Chief Marshal Hugh Dowding visited Farnborough in July 1941. He asked to meet the engineer who fixed the Merlin. Schilling was in Hangar 3, examining a carburetor from a damaged Hurricane. Dowding found her there, grease on her hands, workshop apron over her civilian clothes. "Miss Schilling?" She stood. "Yes, sir. I'm told you've saved more pilots than any squadron commander in Fighter Command." "I fixed a carburetor problem, sir. The pilots saved themselves." Dowding smiled. "The pilots tell a different story." He shook her hand. "The Royal Air Force owes you a debt we can never fully repay." January 1948. 7 years after the first test flight. Beatrice Schilling was appointed Officer of the Order of the British Empire for services to aircraft engineering during wartime. The citation didn't mention the brass restrictor specifically. Official records called it significant contributions to fighter aircraft performance and reliability. Pilots knew better. At the OBE ceremony, 3 former RAF squadron leaders attended. They'd flown Hurricanes and Spitfires during the Battle of Britain and the defense of Malta. All 3 wore Miss Schilling's orifice pins, unofficial squadron memorabilia made from actual brass restrictors. When Schilling received her medal, they saluted. Late 1943, Rolls-Royce finally completed development of the pressure carburetor. Superior design, fuel injection style performance, no float chamber, no flooding under any flight conditions. The Air Ministry ordered all Merlin engines upgraded to the new carburetor system. Schilling's brass restrictor was officially obsolete, but pilots kept them. Tucked in flight suit pockets, mounted on keychains, displayed in squadron-ready rooms, small brass circles, precisely machined holes, 47 cents of material, symbols of the engineer who refused to wait while young men died. After the war, Schilling returned to Farnborough. She never spoke publicly about the restrictor, never gave interviews, never wrote a memoir. She continued her research on combustion efficiency and fuel systems until her retirement in 1969. Colleagues remembered her the same way pilots did: precise, fearless, uncompromising. She died in 1990 at age 81. Her obituary in the Times mentioned her OBE, her motorcycle racing career, her engineering contributions. It didn't mention that she'd saved 2,100 lives with a piece of brass small enough to fit in her palm. But every pilot who flew a Merlin-powered fighter between 1941 and 1943 knew. They knew exactly what Beatrice Schilling had done. Royal Air Force Museum, Hendon. Display case 47B. A small brass restrictor sits on black velvet under museum lighting. 0.06-inch orifice diameter. Precisely machined threads. 81 years old. Visitors walk past it constantly. Most don't stop. It looks unremarkable. A simple mechanical component, the kind of part you'd find in any hardware store. The placard reads, Ray Fuel Flow Restrictor, designed by Beatrice Schilling, 1941, installed in all RAF fighter aircraft to prevent carburetor flooding during -G maneuvers. It doesn't mention the 2,100 lives. It doesn't describe the 1.5 seconds of silence that killed British pilots before March 1941. It doesn't explain what it felt like to watch Squadron Leader Davies climb into his Hurricane, knowing the brass restrictor hidden in his fuel line was either salvation or career-ending failure. But the brass circle remembers. History turns on moments like these, not the massive industrial programs, not the 1,000-bomber raids, not the grand strategies planned in war rooms. The moments where one person, facing an impossible problem, institutional resistance, and a ticking clock, refuses to accept that the solution will take 2 years. Schilling didn't invent a new technology. She didn't revolutionize engineering theory. She looked at a problem killing young men and asked the simplest possible question. What's the smallest change that stops the dying? 50 cents of brass, 11 minutes of installation time. 2,100 pilots who returned to their airfields instead of crashing into the English Channel. Beatrice Schilling wasn't the only woman who changed the course of World War II from an engineering laboratory. Hedy Lamarr invented frequency-hopping spread-spectrum technology, the foundation of modern Wi-Fi and Bluetooth, while working on radio-controlled torpedoes. Grace Hopper developed the first compiler for computer programming languages, enabling the code-breaking efforts that shortened the war. The ENIAC programmers, 6 women who created the first general-purpose computer programs, remained uncredited for decades. Their names didn't appear in textbooks. Their contributions were classified or ignored. Their genius was attributed to the men they worked alongside. But their work shaped the world we live in. March 14, 1941. 7:42 a.m. Beatrice Schilling stood on frozen tarmac, watching Squadron Leader Davies climb into his Hurricane. She held a leather satchel containing a brass restrictor and the knowledge that she was either about to save the Royal Air Force or destroy her career. The choice wasn't really a choice. Young men were dying. She had a solution. Everything else was secondary. Davies flew that morning. He pushed through 6 hard -G dives. The Merlin never faltered. By June, 2,315 fighters carried her restrictor. By war's end, 2,100 pilots owed their lives to a woman most of them never met. Innovation doesn't always require genius. Sometimes it requires the courage to act when everyone else is waiting for permission. Sometimes it requires seeing the simple solution everyone else dismissed as too obvious. Sometimes it requires a 50-cent piece of brass and the absolute certainty that lives matter more than protocols. Beatrice Schilling had that courage. The brass circle in display case 47B proves it.